Welcome to Intro to Translation Part 2. What your partner learned and they will be able to show you is how did they take this original image, the pre-image, it was originally this figure right over here, a square, and we translated it. We made this figure slide over to this spot right over here. So we translated by following a certain rule. And the rule was we had to move each point to the right 6 spaces, so that was the horizontal, and then 4 spaces vertically. So we basically took each point, point A, we moved it 6 spaces to the right, 1, 2, 3, 4, 5, 6, and then vertically up 4 spaces, 1, 2, 3, 4, and then we ended up with A prime. So this point translated over to that point, following this rule that we named right over here. So B translated over to B prime, C translated over to C prime, and then D translated over to D prime by moving each of these points horizontally 6 spaces to the right and vertically 4 spaces up. Now, is this always going to be the rule? No, we could have moved it right 3 spaces or even to the left 3 spaces or whatever. The whole idea of translation is you want to move each point horizontally a certain distance and vertically a certain distance. Now, after you end up with a translated figure, what we call these are the pre-image. This is the image that I started off with. Alright, this is the started everything off. And then we ended up with an image. Basically, it's the copied picture of that pre-image. That's why we put the little prime symbols on it. Because it's a copy of this. We basically copied and pasted it by following this rule. Now, a few terminologies that you will be able to represent and get to know and identify yourself with are vector and magnitude. Now, in order for us to be able to translate this square over to basically over here or anywhere we want it to be by keeping and preserving the angle measurements, keeping them 90 degrees, and basically the length of the segments. The length here is 1, 2, 3, 4 units for each of these sides for the square, and also here 1, 2, 3, 4 units over here on the square. Now, in order for us to be able to do that and preserve the measurements of the square and move each point precisely the same way in the same distance, we have to represent it by something called a vector. Now, in order for us to be able to use a vector, we have to know the direction that we want to translate this figure in and the distance. How far do we want each point to be from each other? That's the translated points, of course. Now, your partner will show you how to do the direction part. That's whether we want to go right 6, up, left, whatever it may be, okay? And then you will be responsible for the distance between the corresponding points, and that is the magnitude. That is part 2 of the vector. That's the length and the distance between corresponding points. Those are the points in the same position in both images. So if I'm looking at the left top point of the square, which is point A, the corresponding point that goes in this square will be A prime. It will be the left top point. B corresponds with B prime, C with C prime, and D with D prime. And what I want to know in order for me to be able to use this vector that you'll get to know later on in class is how far apart are these translated points from each other. And when you think about distance of coordinate points, what should pop in your head? Distance formula. So in order for us to use the distance formula, we need to know the coordinate points of the corresponding points. So if I want to look at coordinate A, the coordinate point for A, that is -5, -1. So let's go ahead and write that in. So point A is -5, comma, -1. Let's go ahead and move it. Alright, there we go. Coordinate B is -1, -1. Comma, -1. And I'll leave the other ones for you to do on your own. So I want to find the distance from point A to its translated point, A prime. So I also need to know the coordinate point of this point. So what are the coordinates of this point? That's going to be over 1 and 1, 2, 3. So 1, comma, 3. So that is the coordinate for this point, and then the coordinate for b prime is over 5 and up 3. So that will be 5 comma 3. So in order for me to be able to finish off what I need to know about this vector, the distance that I translated each of these points, I need to use this distance formula. So basically I need to know the distance from this point over to that point. So what you would do is you would use the translated point as your x2, y2. Okay, so let's go ahead and write that in. That'll be your x2, y2. And then your pre-image point would be your x1, y1. And then we plug in those values into the distance formula, and then we find what is that distance that we traveled from point A to its translated point A prime. So we plug in x2, which is 1, minus x1, which is -5, so minus -5, remember that, and then square it, plus y2, which is 3, minus y1, which is -1, minus -1, and then square that. Add the two numbers up, take the square root. So while you are doing that, I'll do this on the computer. Okay, and then my distance, you should end up with 7.21 or 7.2. In this case, we're not using any units, so we're just going to put the word units, 7.2 units. So the distance from my original point, my pre-image A, to its translated A prime, was 7.2 units. That is how far I went with these points. That is the distance that I traveled. Now, let's go ahead and look at B. x2, y2 will be 5, 3. x1, y1 will be -1, -1. Go ahead and plug those values into your distance formula. I'll do it the fast way, and I will connect B to B prime, and I will see what the distance is. Well, look at that. It is also 7.21. So what I will leave for you to do on your papers is go ahead and use the distance formula for C and D, and let's see what you end up with for your distance between your original pre-image points and their translated points. So what we learned today is basically the distance. Once you have your pre-image and your image, once you are done with the translation piece, once you have used the direction that you want the vector to move your translation, you then are able to calculate the distance that you traveled from one point to the other, from one point to its translated point. I didn't go from A to B, I didn't go from A to C, I went from A to A prime, because these are the corresponding points. How far away did I go from one point to another? And that got me the magnitude, the length, the distance between those points. And that is part 2 of what you need to understand about vector, which will be covered in class. Okie doke. See y'all.